don't know me, my name is Daniel. I'm a software engineer at FirstBet. We are the ones with the nice small birdie that we can see on people's notebooks. And we at FirstBet, as I already mentioned, work a lot with Scala, a lot with Akka, a lot with Clay. So we just use mainly the Lightband stack. That's everything about FirstBet you need to know. So we have all of my colleagues and I have day-to-day work experience with those things, and today I spent half of the day tweaking Akka streams a bit, or at least exploring with new features that are very useful, and I'd like to share my experiences with you. So just the basics. What is Akka streams? As I already mentioned, Akka is a distributed computing concurrent it's a library. It's not even a framework. And as it sounds, it's very low level. And usually you don't like to work with things like message passing directly, because those are things that you bake into the libraries, or you bake into frameworks, you bake into the underlying machinery that powers your applications. That's why Lightband,
May I ask stupid questions?
For sure.
Great.
You're welcome.
Streams. Is this something like Java streams, like you just get stuff out and maybe you get stuff out later, like an endless infinite list kind of data collection thing?
Actually, up to some degree it is. So you might be you might recognize the syntax, because the syntax is the same syntax that Scala uses for, or it's inspired by the Scala collections syntax. So therefore, it also looks similar to the Java 8 streams, and that's also one power of it, that it's easy to use and it's recognized by people that just know the normal collections API. So this Akka streams thing is just another layer of abstraction, and that sounds pretty bad sometimes, but it's just a convenient API to use Akka, to use the power of all this concurrent stuff under the hood that gives you a lot of performance. And actually it's reactive streams implementation. So reactive streams, maybe some of you heard it in Java 9. There comes this publisher-subscriber model to Java, so there they define common API for doing pub-sub or publish-subscribe things. And the reactive streams project, it's just the predecessor of this Java 9 API. And what's really cool for Akka streams? What does it decide for, or what's the difference for example, the Java streams or RX Java or RX whatever, the whole RX library family? So one of the core principles of it is back pressure. Who of you is familiar with RX Java or RxJS, RX Kotlin, whatever? Who of you is familiar with any pub-sub bus, like Guava pub-sub bus, or any of those in-memory publish-subscribe mechanisms? So usually they work like that. That you have a publisher that just keeps publishing things, so maybe you have somewhere an event bus and you just shoot out all the time the events or whatever messages. And when you're a subscriber, you are actually a bit doomed. Because what happens when you have to process more messages than you can actually handle? I mean, we are in the JVM, we have limited resources, so either your CPU makes problems, or you run out of, your thread pool is starving or whatever. So you usually run out of resources when you have a fast publisher and a slow subscriber. And back pressuring, as it already says, it's back pressure, or it tells the source of your thing. So maybe think of it a bit like your kitchen sink. The terminology that Akka Streams uses is source, flow, and sink. So think of your kitchen sink. You have the tap, you turn on the water, and the water flows into the sink. So a source is just where the stuff you're doing or the stuff you're producing comes from. The flow is everything in the middle, and the sink is where it goes to. As simple as that. And, the one thing that's special for Akka Streams is that it's a pool-based model. So the sink tells the sink tells the stage, they're called stages. The stages upstream if it needs more elements or not. So if you're not able to process more elements, you just don't signal upstream that you need more elements. And therefore, upstream will just don't send you more elements, and as soon as you're capable of producing or consuming more, you just ask for more. And how does that look like? As I already said, it looks a bit like the Java 8 streams or the Scala collection API. So, I mean, that's actually different, but the stages in between look the same way. So as I already said, you define source, like your tap, you define a sink, the kitchen sink where the water flows into, and you define a flow in the middle. So you know those coloring taps where you can say, yeah, let's with light make my water look green. So that would be a flow. Just make transparent water green. The API is actually quite nice. Yeah, and it's a kitchen sink actually. What the real power of it is that the difference to the Java 8 collections API or the normal Scala collections, under the hood you have a vast machinery of concurrent processing functionality. So you can do things like initial delay, you can do buffering, you can even do rate limiting with that thing. And actually, just with a fluent API, you can do delays, and there are many more. So you can even model anything with it. We today, and that was the cool thing we did. Who of you knows what the Quartz scheduler? I mean, Quartz scheduler is a popular project, and we today built the Quartz scheduler that is back pressuring. So as soon as we can't process the tasks that or the jobs that the Quartz scheduler issues, we suspend it and resume it as soon as we are capable of consuming more of the jobs. That's what we today built with Akka Streams. So the documentation is quite extensive. You can look it up at akka.com, I think, or org, I don't know, akka.net, I don't know. And you will find a lot of those small convenience methods that help you just transform your elements, that help you merge streams together, that help you do rate limiting. Actually, the rate limiting thing is one of the coolest things it can do. So when you have rate limited API just in stream in front of it, then you'll never get problems with rate limits anymore. One cool thing, and actually that's one of my, I wouldn't call it, or one of the things I really love about it. There are spin-off projects of it that are also maintained by Lightman, and one of these projects is Alpaca. Who of you knows Apache Camel? So the enterprise integration pattern thingy of Apache. Lightman came up with an idea. It's called Alpaca for a reason. I mean, Camel and all those. I mean, they're a bit same. The alpacas are the one that spits, or no, the llamas. But what they try to do is doing enterprise integrations. They call it right. What they do there is actually you can see almost anything as a stream. So when you think of a message queue, so Camel has all kinds of message queue, message broker integrations. What comes from a message queue is actually a stream. What comes from anything, you can, if you work a bit with that, you will see anything as a stream. So you see streams there and there. And with Alpaca, they provide for, I think right now, around 20 message brokers or whatever third-party applications. They provide a common API that builds on top of Akka Stream, so you can consume messages from message queues and from things like that. You can read from DynamoDB, you can read files from S3. They provide an extensive list of integrations there. And you can do even more cool things like database access. So every one of us knows, you need to read something from the database, and actually for your use, you need to transform it. Usually we just load everything in memory, then we transform it. Everyone knows that from Java or any language, and then we return what we transform. With Akka Streams, there's Slick. Slick is a popular relational data access library from Lightman, and that one exposes a publisher. Publisher is this reactive streams interface for publishing things, and Akka integrates with that quite nicely with the source from publisher. So you take a publisher which is push-based, or not even push-based, but it has another API, and you put it into an Akka Stream source, and you can then just stream the records off the database, which is quite nice because you just load what you actually are processing and not everything. You can do HTTP with it. Akka has a project that is called Akka HTTP, which is an HTTP server implementation on top of Akka and Akka Streams. And the idea behind that, it's fairly easy, because what are HTTP requests and HTTP responses actually? You stream packages from the socket to, you just stream packages via the socket. So why not seeing HTTP requests as streams? Every one of us is used to, okay, I get the full HTTP request, I unmarshal it to JSON or whatever, to a class, and then I process it, but you can actually stream it and you can back pressure the socket. So if you're not capable of, for example, taking file upload or something like that, if you're not capable of consuming the rate that the client wants, you just tell the client, hey, sorry, you have to wait a few minutes, a few seconds, milliseconds, whatever. And the same goes for responses. There are so many examples where you have you stream tweets via HTTP. You can do that. You just hook in and you hook in some source, maybe the database, and just stream out a continuous HTTP response where every line is a JSON message or something like that. And Akka HTTP is completely built on top of Akka Streams, because this streaming processing model is really capable of doing a lot of things. You can do I/O with it, you can model business logic with it. We at first mostly use it for higher level business logic things, because processing data or business transactions can be modeled as streams as well. But it's capable also of very low level things like file I/O or general I/O. One thing I'd like to mention here, that on the last Scala coding workshop here at Stockwerk of the Scala user group, Otto and I, we worked on paged API, on an Akka extension for paged APIs. So everyone knows paged HTTP APIs. Also databases provide paged APIs. And we tried to come up with a source that just continuously requests new pages if you need them. So you request a page, you process it, and as soon as you get more, or as soon as you have more demand, you just request the next page. And what does I'm talking here a lot of cool things. No one, or not all of you have seen those things before, but what do streams give me? Actually, one of the coolest things is they allow you to reduce the memory footprint of your application. So you don't hold everything in memory. You just, you request it as you go, and if you don't need it, the garbage collector. If you don't need it anymore, the garbage collector just takes it away from you. So take an example. AWS S3. Everyone knows what it is. It's just the file storage on AWS. And imagine you upload a file from via the HTTP API. Usually what you do, you store it somewhere as a temp file on your server so that you don't have to hold the whole file in memory. And then you somehow use the basic Java streams, not the Java 8 streams, not the buffered reader, whatever thing, to stream that up. With Akka streams, for example, we implemented it that the file goes directly in one flow from the browser to our HTTP server to S3 without bloating memory anywhere, which is quite nice. And what we did today was we thought of, we have some kind of scheduled task that I already mentioned with parts that need to run, and we just don't want to run 100 at a time, but maybe just 4. And you can just define it. So you have a task, let's run 4 in parallel. And if they are not finished, then we can't run another one. And you can really back pressure and signal upstream that you're not capable of doing more than you're currently doing. I also prepared a small code sample because that's one functionality I found just lately on that it's inside of Akka streams, and I think they implemented it 4 or 5 versions ago. And it's the example of a back pressuring in-memory publish subscribe bus. So do you have a vast idea what back pressuring publish subscribe bus is about? So publish subscribe is, I think everyone knows what that is. When you take, for example, the Guava bus, it's one of those buses that I mentioned where the producer throws messages in, and if the consumers are too slow, the consumers are doomed. And the event stream with basic Akka with the basic Akka functionalities that I built is what that one is doing. As soon as you can subscribe multiple publishers, you can subscribe multiple consumers, you can publish from multiple sources to it, and it will back pressure as soon as one of the consumers is not capable of consuming the message, and so that all producers know, okay, I have to wait. And I can even show that it works. So I wrote a small test, and what I do there is here I create my event stream, and as I already said, everything is like a flow or a sync or whatever, and that's just a flow of strings where I just say, okay, I take just one element. So that also exists in the Java 8 streams, that you just say take one and you just get a stream of one element. And I say, okay, I just want to print out every element I get via my bus. Then as I subscribe my sync to it, I also provided another convenience method to just put in a function from whatever the stream it is. Here it's a string to unit. So unit is void. So in Scala everything is an object. Even void is an object. And then I can publish a single message. I can publish a whole source of messages. I can even publish a list or whatever. Doesn't matter. Forget about that. That's just making it run in the test. So it really finishes and prints something. And the implementation actually is really straightforward and contains of just a few lines of code. Actually, that's the basic implementation of what it means. So they call it merge hub and broadcast hub. So I mean, merge hub is just you merge multiple sources into one, and broadcast hub is you broadcast your messages to multiple consumers. And as you can see, as they work just with those three types that everything is built on top of, so the source, the flow, and the sync, you can directly put them together. Ignore the kill switch is just shut that thing down, so stop the stream. And yeah, then just convenience methods for subscribing. So I just say, okay, run that stream with another sync, or run it with a for each sync that was where just put in the function into subscribe, and you just say, okay, yeah, publish sources messages. So take the source, send it to the merge stage, and run that thing.
Every time I see Scala code, I see so much death. Every time I see Kotlin code, I see so much fun. Yes, at least someone got
Yeah, I can't change the Scala syntax. Yeah, actually, that was my talk. I hope I kept it short. I hope you liked it. That was my today's experience with the streams again. If you have any questions, yeah, feel free to ask.
Thank you first of all for this talk which you have prepared right now. It was amazing.
One question. If you work with stream-oriented stuff, did you also see the graphs? The Akka graph, you can build more or less graphs.
Yeah, I didn't want to come up with that. What we just saw here are actually linear graphs. I mean, well, the stream. Okay, a stream. You know what graphs are? Graph from mathematics. A stream is actually a linear graph, and you can always just say, yeah, in the middle of the stream, just have another branch or another branch or another one. You can even have circular streams, even if it's not a good idea, but you can do that. It's a nice API. It's quite low level, I would say, because you can do very powerful things with it. You can just define a branch because of it. For example, you just want to log something or you want to audit something, so you can just have a branch that takes the message and logs it or writes it to an audit trail, whatever. Actually, there are three levels of APIs in Akka streams. There's this very high level API that looks like almost every functional collection API, and then you have one medium level API, that's the graph API, and then you have a very low level API where you can do almost anything with it, but it's more a thing for library authors than for application developers.